In this question, let f such that D is mapped onto R and D is the domain, where f of x is equal to x on x plus 1, where D is the largest subset of R for which f is defined. In other words, it's the biggest domain that is contained in all real numbers. So part A, express f of x in the form f of x equals a on x plus b plus capital B. So f of x is equal to, and there's a neat little trick so you don't have to do long division for this. So the way you do it is you just make the top look like the bottom. So you go x plus 1 over x plus 1. And then to undo what you just did here, you would just minus 1, and so that top is still equal to x. And then what you do is separate this into two fractions. So x plus 1 over x plus 1, and then minus 1 on x plus 1. And you can do this, it's just like if you have 1/4 plus 1/4, that's just really the same as 1 plus 1 on 4, which equals 2/4. And you're really just going from this step to that step, so separating the addition of two things on the top into two separate fractions over the same denominator. And so this equals 1, and that's the whole idea of making the top look like the bottom to start with. So this part's going to equal 1, and that's that bit, and then you're left with 1 on x plus 1. So what you now need to do is write it like this. So I'm going to put this term first, so minus 1 on x plus 1, and then plus this 1. And it's not obvious here, but this a, the number on top, is actually going to be minus 1, because you could write this as equal to minus 1 on x plus 1, like that, and then plus 1. And that's more, and this is just the same as this. So, and it's a bit like if you have, say, minus 1 on 4, that could be the same as, or is the same as 1 on minus 4, and you would write the whole thing as minus 1/4. And that's all I've done here to get rid of the minus in front of the whole thing. So that's part A done. In part B, state D. So D again is the domain. So remember, this part at the front is always the domain. And so looking at this here, the only x values that you can't have are, well, in this particular case, this bottom part of the fraction, the denominator cannot equal 0. So that would in fact be a vertical asymptote. And I didn't really want that to be yellow, but we'll do it anyway. So the vertical asymptote, and now change to, so, and you find that by letting that bottom equal 0, and from there x would equal minus 1, and that is actually giving you the asymptote. And just quickly drawing this, so the asymptote of minus 1, and then this plus 1 moves the whole graph up 1, or actually that's the horizontal asymptote, and then because it's a negative type of hyperbola, it's going to be in these corners here. So from there, this is the vertical asymptote is always the one value, or a value, that x cannot equal. So that means that x can be any other number except for minus 1. So the domain D is going to equal R except for the value of minus 1, and that's a squiggly bracket. All right, so that's the domain D, and that's the answer to part B. In part C, on the axes below, sketch the graph of the function with equation y equals f of x. This was f of x, and really all they're saying is because the axes, or this axis, the vertical axis, is labeled y, then you're just going to let y equal this function and then sketch it. So clearly mark the coordinates of the points of intersection with the axes. So that means you have to find the intercepts and clearly label any asymptotes with their equations. Alright, so if you remember from before, I had the vertical asymptote, And I'll just run through that again. It's always just letting the bottom equal 0, so x plus 1 equals 0. From there, x equals minus 1. So drawing that asymptote in, vertical asymptote going through here like that, x equals minus 1. And then the horizontal asymptote is always this number that's been added or subtracted at the end, and it's y equal to that number. And I'll put the step in, so horizontal asymptote is just y equals positive 1, and that's a horizontal line going through 1. So marking that in, y equals 1. And then, as I mentioned before, this is a negative 1 on x type graph, so the positive is always in these two corners and the negative is in these two corners. So I'll do this in a different color. So you're going to have something happening like that, and the other one's going to go in here somewhere, so you really need to find the x and y intercepts first. So y intercept first, usually the easiest one. So x is 0, so subbing 0 into here you get y equals minus 1 on, so 0 plus 1 is 1, and then plus 1, and then this equals minus 1 plus 1, which equals 0. So that means if y is 0, x is going to be 0. And so you don't really need to work out the x-intercept, seeing as it's going through this point. All right, so that's a little bit better. And just make yours a bit smoother than that. And voila, there you go. And marking in the axis intercepts, that's going to be 0, 0, and that's all that has to be done for that one. So that's how you do that question.